Okay, so when you have an object through the air, for instance a satellite, we have, here's my Earth, right? We have an object and we'll launch it out with some sort of velocity. Well, if we give it more velocity, it's going to go further and further and further and further. So if you give it more velocity, eventually it continues around in a giant circle because it has enough velocity to keep it going. And the Earth starts to fall away from its path. So it's still falling, it's just the Earth is falling away too, in a sense. The Earth is curving away from its path. So that's what we call orbit. So the more velocity you give it, the higher up or the further away it's going to go, and the faster it needs to go to stay at that orbit. So there's no force that's, keeping it in a circular path. The only force that's really acting on it is gravity. It's just it has velocity that keeps it going around. So it's forever falling. Any questions with that? I see one red. Make sure I can see your red cuts from my point of view. All right, so here's the equation for the period of an object orbiting something. It doesn't have to be a satellite. A moon is considered a satellite. So it could be the Earth around the sun. It could be a satellite around Mercury. It doesn't really matter. So this is the period, in other words, the time it takes to make one revolution. 2 pi times the square root, and r in this case is the distance between the centers of the two objects. So most of your problems are like the distance between the Earth and the Moon. That's assuming that it's between the centers. If it's talking about a satellite, then you need to account for the radius of the Earth or planet as well. So for instance, the problem would say something like the satellite orbits at an altitude of 10 meters or 1,000 kilometers or something like that. So you'll need to add that 1,000 kilometers to the radius of the Earth, because r in this equation means the total distance between the center of the Earth to the satellite. So if this is the satellite, this would be the radius of the Earth plus the height or the altitude. So you need to put both of those into the equation in this r. So this r is talking about the total distance between the two things. That depends on your problem. But if it's a satellite with a height, then you need to add the r in as well. We'll do one like it. This is over g, which remember g is 6.67 times 10 to the negative 11. It's got some crazy units on it. I don't remember them. And this mass is what it's orbiting, the mass at the center. It does not matter what the satellite is. Something that is orbiting at the same distance as the moon is going to have the same period as the moon and the same velocity as the moon. It doesn't matter if it's the size of the moon or not. It could be you out there. But if it's at that distance from the moon and it's orbiting, it's going to have the same period, same velocity.
What's that thing next to the R?
A cube?
No, in the picture.
That is the symbol for Earth, which looks like this. That just means Earth. Anybody else? I see all blue cups. Again, make sure I can see your cups. Okay, moving on. The next equation that I'm going to give you is the velocity of a satellite. The velocity of a satellite is, it comes from mass, let's see, F equals ma, where you're looking at centripetal acceleration since it's orbiting. And the gravitational force one that we learned on Friday, the F equals g mm over r squared. If you put these two things together, you can solve for velocity. It's not really important that you're putting these two things together. But the velocity of a satellite is going to be equal to the square root of g m. And again, this mass is whatever it happens to be orbiting, not the mass of the satellite, over that distance. And again, this distance is between the centers. So it could be radius plus height. I do have a proof for this if you're interested. You don't really need to write it down. It's not that important. But it is kind of interesting. So I'll write it down over here on the side. If you start with F equals MAC, you also have F equals GMM over R squared. One of these is the satellite, right, the mass of the satellite, and one of these is the planet, which we'll just say Earth for now, just a proof. So these two forces are equivalent. The force of gravity in this case is the centripetal force because it's what's causing the object to change direction. So you can set these two things equal to each other since they're the same force. And this is the mass of the satellite. The masses cancel. AC turns into V squared over R. You have R's on both sides, you can take them out, and you're going to do the square root, so V equals the square root of GM over R. So that's where it comes from. Not really important that you know that, but it is interesting if you like math.
What's the meaning?
The planet. So usually a satellite is around a planet, but it could be the sun, it could be whatever it is you're orbiting. If you're in space and you have an apple orbiting, it would be your mass.
What about the
The S is satellite. The S is satellite. Okay, I see blue cups still. So here is the next one. We're going to do a practice. This practice, remember the first thing you want to do is read it. It says the satellite is orbiting at 350 kilometers above the Earth. The radius of the Earth is a very large number, and the mass of the Earth is a very large number. What's the velocity and period of the satellite? So the first thing you want to do is write down those numbers. We have 350 kilometers. We have 6.38 times 10 to the 6 meters. And 5.97 times 10 to the 24 kilograms. What is this 350 kilometers?
height above the Earth?
The height. Good. The height above the Earth. And what's wrong with it? It's in kilometers, so we need to change it. And all I do is change the K, which means times 10 to the 3, into an actual 10 to the 3. You can fix it if you want, but for mathematical purposes, that'll work just fine. All right, what's this 6.38 times 10 to the 6? It's the radius of the Earth, good. And what is this 5.97 times 10 to the 24? Mass of what? The Earth. Okay. Part A, what is part A asking for? Velocity. Okay, so we're going to plug it into this velocity equation. Velocity is going to be the square root of 6.67 times 10 to the negative 11 times the mass, which is 5.97 times 10 to the 24 over your distance. Now, this R, again, is not just the radius. It's the total distance between the center and the satellite. So what is that going to be here? You got to add them up. You got to go R plus H. So you're going plus H over here. So this is going to be 6.38 times 10 to the 6 plus 350 times 10 to the 3, and then you've got it. Now, what I would like you to do is try to enter all this stuff in your calculator at once instead of doing step by step in your calculator, because you can go back and fix your mistakes a lot easier. That means that you're going to need an extra parentheses here and here. Mm-hmm. And this gets your velocity to be 7,694, I think. Depends on how you round. If you're using pi or if you're using 3.14, I guess. Okay, so what I want you to do is make sure you get this in your calculator. This is pretty much what this chapter is about. Yes, it's about gravitation. Yes, there are equations, but I mean, once you have the equation, it's not a big deal. What this chapter is mostly focusing on is, can you use scientific notation correctly, and input it into the calculator. So these are very complicated, large numbers and equations, and we're going to put those together. So that's why I want you to practice this. So I'm going to walk around. I want to look at what you're putting in if you're struggling, so don't erase it. Yes?
Why did you add the H in there?
Because it is the distance between the centers. So it's the radius plus the height. We just did the height and not taking into account that the Earth actually has the same size.
So the height's always going to be
I mean, it depends on what the question looks like. If the question says the distance between the Earth and the Moon is like 5 million something, then it's already done. But if it's saying that it's the height of a satellite, then it's not including the Earth as well.
Okay.
Got it? Okay. Yes.
Because this is not included. This is square root.
I think mine actually is
And then you just, so she just wanted us to plug this in. Like all the add. It's like this equation.
It's not even dumb. Oh wait, yeah, it is.
You're doing this times
When do you think I could have what I got on?
As soon as I sit down and do it, which will probably be between one of these classes.
It won't work here. Quarter of a There you should do you have it 6, 7, 11? The other? But see, you added one here, but there's no one front. Because you added this here, without the extra one there, it did the square root of the top part, then divided by the bottom.
What's the M?
You have to add an extra one in the beginning, and you have to double it all one equation.
Oh, you feel that? What did you hit? I got the E.
Second. The double.
There has to be another one here. It has to be like that.
Wait. Hold on. I can go back.
Because that one tells you that this whole function is together. And that one tells you that the top part is multiplied. Otherwise,
Yeah, those parentheses. Not joking around.
that's what I got. Oh, I got it right.
Sure got 2 points. There we go.
I got 0. Do we put this in our clear?
No.
Just make sure you're getting my answer. I got it. Do we solve for 18?
Wait, you laughed just like.
You got bubble. There's 4 and 2. Yeah. Until what?
Alright, I'll make sure I get your last.
2 and 6, 9. Is that Oh, okay. I was like, I thought that was a 4.
Don't encourage him.
Don't encourage him.
Did you get 5,000? She didn't do it.
I'm doing it right. Hey, I'm doing it right now.
Boy.
I did not.
I wish we just actually
I don't know where you get that from.
So just so goes until I get it.
Are you cubing that first? Are you putting it all in? Use the first equation.
What?
Use the first equation to experience.
I was so sick.
It's 6.67 times 10 to the
9.07. How do I clear this glass?
I don't think that's right. Did you put it all in?
You missed a bunch of brackets.
Okay, now let's try the period. Using this equation here, find the period. T equals. All right, this is going to be T equals 2 pi times the square root, and that's that R again. You need to do H plus R. So 350 times 10 to the 3 plus 6.38 times 10 to the 6. Cube this. On the bottom, you're going to have G. And what's the other one? M. M is 5.97 times 10 to the 24. Okay, now your calculator likes parentheses. It wants you to tell it what it wants to be done first. So you need to make sure you put a parentheses here, and here, and there. That should be enough. Yeah, in the front it'll be 3.
Hey, that's not what I have on the top.
Let me see what you.
I know, I missed it. How? Because you had to add the height.
Yours is going to look more like, if you're putting this in the calculator, it's going to look more like this. Like that. There you go. That should work.
Why are we putting the height in the top this time?
Huh? Because we were using a different equation.
I know, but it still doesn't ask for height.
Right. And it's because it's the distance between the center of the two objects. If the question says, what is the force between the Earth and the Moon, then it's already taking into account the radius of the objects. If it's saying, what is it of a satellite, and the height of the satellite is 400 meters above the Earth, you need to include the Earth too. So that's why I'm doing an altitude problem for you, because you have to include both of those.
Is there supposed to be 3 parentheses on that?
Yes, there is, because I'm doing the bottom. Like I have them each multiplied by each other, then I'm doing the bottom. Because if I don't put that in there, then it's going to divide just the first number, not both. And then the last one is because I'm square rooting.
Okay, so I should get that.
You can get it.
So, is it up? Oh.
Make sure you get my answer.
So like what you did isn't going to change anything else in my calculator from that. Oh, it did. It definitely did. With that, I'll do a fraction for you here. You ready? I try to change it to a decimal. Oh, you know what? It's not right. How can you do that?
We have the same calculator. It's pretty much the same.
What the
Holy numbers. I mean, it's a square root, but it's the same thing. Then you have to do that.
It's all my answers.
Oh, triangle thing. Who's Miss S? Where's she at?
I'm a try. Why can't you do it? Yeah, I know. Oh, I forgot to end first.
I think most of you have to do that on there. But it should be
I think it's great. Too good to be.
No, you have to do it. Oh, she did it.
You're doing it wrong. You're studying.
Yeah, because you're doing it so
You're doing everything to the third power. That whole thing is
You like Steve that either?
What?
No, I'm not. Just like, I forgot that last stuff that's turning on. I'm just doing it separately.
Yeah.
I got .0008
because at the very end of the first one, we had that whole whatever. You did it there. But there's no.
Well, see,
You have the inspiration.
I don't really know.
Yeah. I always have to play for all.
Is it three? Is it the top three and the bottom three?
Oh, you gotta do it all at once, so I can stop.
And then there was a thing out at the top.
All at once, then I would go in and fix it. Usually it's just
Because this was cute.
Let me know when you get it all. Delete it. See it.
Yeah.